protocol, right? So let us illustrate. Let me illustrate a graph-based protocol with another example, right? So in the case of graph-based protocol, again, the other thing you need to know that is that some prior knowledge about the data access is needed, right? So for example, you consider this graph. So you have root node A. So the internal nodes are B, C, D, E, F. The leaf nodes are G, H, I, J, right? Now we need to check whether this schedule is a valid schedule. The schedule has a set of transactions. 4 transactions are executed concurrently. T1, T2, T3, and T4. 4 transactions are executed concurrently. You need to check whether this 4 transactions can proceed without any conflicts using a tree-based protocol, right? So in the case of a tree-based protocol or graph-based protocol approach, you need to know the data items that are being accessed by the transaction in advance, right? So let us start with this transaction T1. So initially the schedule, it consists of a sequence of execution of the transaction. So we are going to start the execution of transaction 1, right? So initially the transaction 1 acquires an exclusive mode lock on the data item capital B, right? So the first lock can be on any data item, right? So the exclusive mode lock on data item capital B is being given, and then in the meantime the transaction T2 starts, and the transaction T2 acquires an exclusive mode lock on the data item capital D, right? So if you look into the transaction D, right, again its parent node is locked, and again since it's the first transaction, you can assign lock to the data item capital D. Then it executes, and it acquires an exclusive mode lock on the data item H. So again data item H can be locked because its parent node D is being locked, right? So when the transaction, so let me repeat it. So transaction T1 starts. So transaction T1 can acquire lock on any data item, right? So the first lock can be on any data item. So it's going to request a lock on data item capital B. So it can be granted, right? So here the case that like the parent node has to be locked need not be there. Since it's a first lock, the lock on the data item capital B is being granted. Then there is some context switch. Transaction T2 starts executing. Transaction T2 acquires an exclusive mode lock on data item capital D, right? Again, it's going to be a the transaction T2 is going to acquire a first lock. So first lock can be on any data item. So data item, the exclusive mode lock on data item D is being granted, and transaction T2 wants to acquire an exclusive mode lock on the data item capital H. Since the parent of the node capital H D is being locked by the same transaction, again lock on the data item H is being granted. And next the transaction T2 unlocks the data item capital D, right? So unlocking can happen anytime, right? So we are going to unlock the data item capital D. So again there is some context switch. Now transaction T1 request an exclusive mode lock on data item capital E. So the parent node of capital E is going to be B, which is already locked by the transaction T1. So exclusive mode lock on transaction E is granted, right? Again transaction T1 request an exclusive mode lock on data item capital D, and since its parent node B is already locked, exclusive mode lock on data item D is granted, and transaction T1 performs unlock on the data item capital B and capital E, right? So again unlocking can be done at any time, right? Now there is a context switch, and the CPU allots the CPU time to the transaction T3. Now transaction T3 request an exclusive mode lock on data item capital B, right? So the first lock by a transaction can be on any data item. So exclusive mode lock on data item capital B is being given. And again, transaction T3 request an exclusive mode lock on data item capital E. And again, since its parent B is locked, we are going to assign exclusive mode lock on data item capital E by transaction T3, right? Now there is again a context switch. You are going to unlock the data item H. Transaction T2 is going to unlock data item H. So again, it's acceptable and unlocking happens. Now transaction T1 starts executing, and transaction T1 it's going to acquire an exclusive mode lock on data item G, right? So since G is a parent node, D is locked. So you will be able to give an exclusive mode lock on the data item capital G, and then you have this unlocking of data node data item D happens, and this is again permitted. Now there is a context switch by the CPU. The CPU time is allocated to transaction T4. Transaction T4 acquires an exclusive mode lock on data item D. So it is granted, and transaction T4 request an exclusive mode lock on data item H. Again, it's granted since its parent node D is being locked, right? Then we have this unlocking of data items D and H happens in the transaction T4, and unlocking of data items E and B happens in the transaction T3, and finally unlocking of data item G happens in the transaction T1, right? So this is a valid schedule because all the transactions can be executed without any conflicts, right? So they will be able to access the data items without any conflicts, and hence it's known as it's a valid schedule, right? So this is how you can check with a graph-based protocol whether a transaction can proceed without any conflicts, or there are some conflicts during the execution of a tree-based protocol, right? So hope you are able to understand the tree-based protocol or graph-based protocol. So the idea is very simple, right? So you are going to acquire only exclusive mode lock on a data item, right? So the exclusive mode lock on a data item alone can be acquired in this case, in the case of tree-based protocol. And initially you can acquire lock on any data item in the tree. So initially when a transaction starts executing, it can acquire any lock on any data item in the tree. The subsequent locks are being allowed only if its parent node is locked, right? So and again we can unlock a particular data point at any point of time, right? So each data items are can be accessed at most once, and relocking by the same transaction is not allowed, right? So given this schedule, we have executed this sequence of instructions by the transaction, and we have seen that so this schedule can execute without any conflict, right? So hope you are able to follow this, right? So whenever you start looking into the schedule, the thing you need to know is that the first lock can be on any data item. The subsequent locks can happen. The subsequent locks on a data item can happen only if its parent node is locked, and the unlocking can happen at any point of time, right? So here even there is some context switch by the CPU between 4 different transactions. All the 4 transactions can execute without any conflicts, right? So it's a valid schedule, right? So this is how we work with tree-based protocol or graph-based protocol in the case of concurrency control techniques, right? So the next